Okay, so this video is intended to help you arrive at a decision about which variables in the data set are suitable for the regression analysis. Because we've got so many variables in the data set, we want to reduce the number that we analyse, and that's for a couple of reasons. One is that the sample size is not that large, so having too many variables in a regression causes issues in terms of statistical power, because the statistical power is not that high. So we want a parsimonious model. We want a regression model that includes the important predictors of the outcome variable. In this case, the outcome variable is healthy lifestyle behaviour. So we want variables that parsimoniously predict healthy lifestyle behaviour scores. So we need to choose variables very carefully, and one way in which we can do that is to have a look at the correlations using Pearson correlations. Have a look at those correlations of the variables with the outcome variable. So we're only really deciding to take variables forward if they significantly correlate with healthy lifestyle behaviour scores variable. So Pearson correlation analysis is always a useful analysis to do if you're intending to do a regression, and you would report correlations in the results as well. But we'll talk about correlations and how we report them later. So the next video we'll talk about regression, but this video is really concerned about the correlation analysis to begin with. But before we do that, I'll just give you a quick outline of what the syntax file looks like, what's in it, and how we've got to the point of analysing the data using that syntax file. So if we look at Blackboard, there is a folder in your Blackboard in the health psychology module called practical assignment, and inside that there are a couple of folders. One of them is called data analysis support, and so I've opened the SPSS data file and I've opened the syntax file, and these two files are videos on YouTube which you should have seen by now on the use of SPSS syntax files to give you an idea of what syntax files can do and how useful they can be. So the next step now then is to actually use the pre-prepared syntax file here, this file, to use that to run some correlation analysis. So I've got SPSS opened and the data file's opened at the bottom here, so we can see the data. We've got 128 cases in the data file, and the syntax file is opened as well. And essentially what we're going to do is skip all of this syntax which works and just move to the bottom of it for the analysis part. So near the bottom you'll see a wee note here. That's not syntax, that's just a note to say what this is. So the first bits of syntax start with the word frequencies, and we're looking for frequencies of question 4 and question 2, and then descriptives is a slightly, this will get us a mean for question 3, which is age, and BMI scores. So we'll have the mean BMI for the sample and the mean age and the standard deviation. So you can see it there on the syntax file. So if we take a look at the PowerPoint here that we're going through in class in week 5, you'll see that this video is going to help you with the descriptives part. We'll talk about the reliabilities. I'll talk through that now, but it's fairly straightforward because the syntax exists, and you only need to report the reliabilities of scales that you use in the regression analysis. Okay, so there are so many scales here, you don't have enough words in the report. For 2,000 words, you need to be quite careful about your use of words. So we only report scales that actually have been used in the regression analysis. I think if we do that consistently, then that's fine. So we will look at these Pearson correlations. So the first two analysis help with your method section, and this third part will help with the beginning of your results section, the Pearson correlations. Okay, so if we go to your syntax file, data file is open. The data file must be open behind this, or the syntax doesn't work. So if the first thing we do is we select frequencies and descriptives, and if we hit the green button below utilities above, that will run that analysis for us. So we can see that we have, it's saying 127 cases have given valid responses. One person is giving a missing response to the year of study question. The gender question, we've got 126 valid responses. 2 respondents didn't answer the question. Minimum and maximum scores are 1 and 2, so that it's male, female here. Okay, so this gives you a breakdown of the sample in terms of the year of study, and your data is included in that. Year 4 students tend to be part-time students, and gender. Okay, so that's done, and then so that's the frequency commands. The descriptive commands were on question 3 in BMI, and they actually give you means and standard deviations of continuous variables. So the frequency tables tell you percentages, and you can write those into your method section under participants. And the descriptives table tell you means and standard deviations of your continuous variables, which again you can write into your method section under participants. So the mean age and the mean BMI of the sample, and the standard deviations, obviously. So that's that. And now, in order to look at the correlations, if we go down and select the syntax file, again the orange one, just open that. The first command after those descriptives command there is in correlations. So if I select that, you'll see we're going to correlate healthy lifestyle behaviour 2 with question 3 BMI, WHO 5, healthy lifestyle intentions, healthy lifestyle attitudes, healthy lifestyle ability, and so on. So we're correlating lifestyle 2 with everything that we think could be a predictor of it. Not all of these will be significant. So let's run that. So we get this long correlation table. So we've got healthy lifestyle on the left here, 2 variable. So that's a summated score. High scores indicate healthier lifestyle behaviours, and lower scores indicate more unhealthy lifestyle behaviour scores. So that's quite a big table. So what I can do is, if I double click on that table to edit it, I can then go to pivot, transpose rows and columns. So I've made it a column table rather than a row table across, so I can see it better. So it's now going downwards. So the first set of numbers here, this column represents the correlations of each variable with healthy lifestyle behaviour. The ones with an asterisk or star indicate significance. 2 stars indicates highly significant. So we've got 1, 2, 3, 4, 5, 6, 7. We've got 7 significant correlations there. So cognitive restraint, uncontrolled eating correlate with the outcome. Openness correlates. Neuroticism doesn't correlate, obviously. Extroversion correlates. And the 2 stars indicate significant at the 1% level. 1 star indicates the 5% level. So 2 stars are more highly significant results. So our biggest correlation is healthy lifestyle ability, HL ability, and it's a positive correlation. Intentions also correlates with the outcome positively. Motivation to comply with family also correlates positively, and we have some negative correlations here. Now, you should also notice or note that just because all of these significant correlations are here, that doesn't mean that they will all be significant predictors of the outcome whenever you run a regression analysis, because regression is asking a different question. It's not asking whether the variables individually correlate with the outcome. It's asking whether each variable uniquely predicts the outcome, controlling for the other variables that you've included in the model. So it's what does each variable add to the prediction, controlling for the other variables. So it's what additional variance is explained by that variable that the other predictors do not explain. So it's a subtly different research question. So we have 7 correlations here, but we will not have 7 unique predictors in the regression. So that's worth bearing in mind. So I would suggest that in terms of reporting a correlation matrix in the results section, then you should only really choose the significant variables here to report in a correlation matrix. So if you look at your correlation, at your syntax file again, here's the regression analysis, and the correlations syntax at the bottom is actually a matrix form. It will give you a table as a matrix. So it's going to correlate every variable with every other variable here. Whereas this was correlating healthy lifestyle behavior against each variable separately. It wasn't correlating these variables among themselves, because if that would give us a very big matrix, which would be difficult to report in the results section. Here we've got 1, 2, 3, 4, 5, 6, 7. We've got 8 variables. We had 7 significant correlations, remember, with the outcome. So we've got 8 variables including the outcome. So we've got 8 variables, and that's more manageable as a correlation table. So if I select that and run that, you get a matrix. So this would be an appendix as well, if rather than in the results. But if you want to turn this into a results APA type style table, then you need to use the Word document that I've given you in Blackboard for correlations, for reporting correlations, and then take the top number in each cell as the correlation and insert those into the formatted table. So the formatted table will look something like this. So it's just got the three lines in the table. We've got 8 variables across here, 8 column variables. So the numbers of these relate to these numbers. So we've got 9 here. So number 9, uncontrolled eating, there is being correlated against number 1. So these numbers are not the right numbers. You need to insert the right numbers, but the format's correct. Okay, so variable 9 is correlating here with number 1, number 2 here, number 3 here, whoops, number 4 here. So you don't need to have a correlation of uncontrolled eating number 9 with uncontrolled eating number 9 here. You only need to correlate 9 with the first 8. So we don't need 9 columns, we only need 8 columns, because this is all possible correlations of uncontrolled eating with all the other variables. So that's